Welcome to a presentation about clean and affordable energy. We are suffering from an energy crisis. Energy is not being produced nearly as clean and well for the environment as it should be, and is not affordable to or accessible to all. This presentation will highlight the importance of clean and affordable energy on a global scale. To begin, living without power. Here is depicted is a person living without power. As you can see, their house is dark. There's no type of climate control, temperature control. They are forced to cook using a bin with a fire in it. That's their source of heating for cooking. Their clothes they have to hand wash and set out to dry. It is a unfortunate situation as a whole. One could imagine how difficult it would be to get ahead in life, live like a healthy, productive lifestyle, especially competing with other countries that have tools and electricity and universal access to power that will let them get ahead of places like this is simply unfair, and the divide in resources is very evident. You can see the impact of places without electricity by a simple picture of the globe at night. As you can see, more modernized places on the planet have lights and signs that they are developed. Meanwhile, less developed places such as South America and Africa are largely darker at night because they simply don't have access to electricity. And this whole graph just shows the divide between people with power and without. Another problem with our current energy crisis is pollution. We are polluting our environment with CO2 emissions from fossil fuel production. Here you can see pictures of cities covered in smog from high CO2 emissions. In the top right, you can see a coal factory producing billions of tons of CO2 emissions into the atmosphere per year. The bottom is a harbor where the powered ships often pollute the environment. And then finally, another picture of a sprawling city that is unfortunately plagued with pollution. It is bad for the environment. It is heating up our planet. Global warming is the annual heat increase caused from higher greenhouse gases prevalent in our atmosphere. Whenever the sun shoots off solar radiation, normally it heats up the planet and then reflects off of our surface and pings back out into space. But with a higher saturation of greenhouse gases, the solar radiation will then reflect back in for a second time, and it will heat up the entire atmosphere, causing our weather to get more severe as time goes on. Here is a graph highlighting our annual average temperature, or highest average temperature since 1967. As you can see, it has steadily increased over time, showing that this is a true phenomenon and a pressing issue. And the rate that it increases is shown to be exponential, so if we do not take action now, it will only become worse and worse. Acid rain is also a side effect of it. As rain falls through CO2 dense skies, it will cling to the CO2, which will acidify the water. This runoff will increase the pH of local lakes and damage the ecosystem. Many river snails and fish are prone to high pH levels and are dying as a result of the higher acidification water. And this is causing disastrous effects on the food chain. And it will only get worse if we do not take action, as more and more animals will succumb to higher acidity in their ecosystems. So what are some greener options? I propose that we should replace fossil fuels with nuclear energy, hydroelectric energy, wind energy, and solar energy. Why are these the best options? We will get into in a second here. The first option is, or for all these options, they have less carbon emissions compared to fossil fuels. As you can see on the first four energy sources here, they are all relying on natural gas and fossil fuels, and they produce a lot of CO2 per kilowatt hours produced in the hundreds compared to nuclear, water, solar, and wind. Their emissions are simply night and day. I would not personally recommend geothermal, as it has a lot of logistical problems and it has simply just not been as well developed. It is not an immediate solution. Now, on cost effectiveness and affordability, which is always a major concern because coal is notoriously a cheap energy source. Here are some graphs depicting that nuclear energy is actually cheaper to produce, which will help with its global affordability. In the top left, you can see that nuclear is by far the least expensive to generate, as 1 ton of uranium produces the same amount of energy as over 900 tons of coal. And that is simply with uranium reactors. Thorium reactors, which is still in development, it's a bit of an experimental tech as it is unstable and still being worked upon. It will be 1,000 times more efficient than uranium reactors, which is estimated around $11 per megawatt hour, which is extremely efficient. The bottom left shows energy returned on energy invested by source. Nuclear is by far the most cost-effective plant to build. In the top right, you can see the materials required, and nuclear is in the bottom bracket of the cost to set up each plant is very cheap to build. And finally, its capacity factor by energy source. Nuclear retains 93% of its power when being produced. It is extremely efficient and it retains nearly all of its energy used to create it. The 7% is simply the amount of energy that you have to use to start the reaction. We'll get into that here. So nuclear energy, the way it works is that there is a reactor core where the uranium is held. When you heat this core, that's the 7% of inefficiency, you have to heat this core and it will start reacting. The individual uranium molecules will start ionizing and start shooting off electrons everywhere, and it'll start a huge chain reaction. And in science, whenever there's a chain reaction and a lot of dynamics in terms of particles changing, it creates a lot of heat, a lot of energy is being produced. We use this heating core to boil water in a river. They're always built on the side of a river or some type of water source. This rapidly heating core will then boil the water, which causes it rise out of those two columns there, and spin a bunch of turbines in there. And these turbines spinning will be converted into kinetic energies, which will power a generator and go to the power grid. That's how nuclear energy produces. It is nothing dangerous. It is all contained within the core, and there are hundreds of measures to make sure that they do not melt down. That's what happened with Chernobyl and other meltdowns in the past. But now we have computers monitoring them alongside people and various extra safety checks, and they are completely safe, and we haven't had a meltdown in decades. The white smog that you see coming out of these pipes is simply water vapor. The only emissions that come directly from this is water vapor, so it is very safe and not very problematic for the environment. That's why I recommend it as our first and most prominent replacement for fossil fuels. Next comes wind turbines. These are also extremely efficient and cheap to produce. They are able to work indefinitely. This is a renewable energy source. Nuclear is the only non-renewable, but it's so efficient it will last us hundreds of years, long enough for us to find a better renewable replacement. And right now, wind is an extremely effective replacement for fossil fuels because it is renewable. Wind's always blowing. They will always be working. And they are cheap to produce. All is a massive propeller, and the wind blows, it spins these propellers, it turns it into kinetic energy, which is turned into electricity. It is extremely efficient and a good solution all around. One of the more expensive replacements, which is it kind of needs time to still be developed, is solar panels. While the cost to produce each panel is higher than other methods, its benefits are undeniable, as it can produce plenty of energy. A single household with a couple panels can produce enough to sustain themselves and a couple other houses on their street. They are very compact. They small. They take the infinite energy from the sun and converts it into power using thermal heat collection. And their major benefit is just how compact they are. As you can see in this picture, they are integrated onto the rooftop of a house. They can easily be set into cities, unlike wind turbines that have to be across large landscapes and fields. They can be right on your house and it would not bother you. It's just right there. Very efficient with land use. And finally, we have hydroelectric. These are multi-purpose, as they both act as a dam to protect lakes and reserve water, and also the water that flows through will spin a water turbine, which produces electricity, of course. They can protect cities from potential flooding. Really useful, multi-purpose, very, very high power output too. They're only really restrained by the fact that you can't just put dams everywhere. Finding areas where you can set up dams is really its major limiter. Here you can see for the wealth gap, percent of low moderate income households bearing the burden of energy. So what this first graph is showing you is that in Alaska, if you're a low to moderate income household, 42% of your bill or income is going directly to supplying electricity. It is a very rural area and there is not much of a power grid, so nearly 50% of their population nearly uses their income to buy individual propane tanks and various levels of direct fuel to power their living, and that is causing them to rate very highly on this, simply because they don't have access to a power grid, and individual level heating is very expensive when you're not going through a grid. Others show low income areas, as you can see on the right. Mississippi, South Carolina, Alabama are all in the highest poverty rates, and this is what I was talking about, drawing the distinction of The lack of access to electricity directly corresponds to poverty and low income because these people simply won't have access to like the internet for education. They won't have, they're too busy focusing on the necessities of survival rather than being able to thrive and compete with a evolving and modernizing world. So this is showing more about the wealth gap in relation to lack of energy. So with our goal, we are going to spread power grids all across the world. We are going to make sure it's affordable with the use of nuclear energy and make sure it's a lot greener than fossil fuels and try to reduce the pollution of our planet before it's too late. In our ideal cities, we will integrate energy production with our urban landscapes. Right now, we usually have West Virginia, for example, producing all of our electricity with their coal mines. Meanwhile, cities simply just reap the benefits of the production. In ideal cities, we will have the energy being produced within the city, have like a nuclear plant on the shore, wind turbines throughout the mountains, solar panels wherever it's available. In the bottom right hand, you can see a park integrating solar panels into its infrastructure. And we're just going to have really efficient green cities that will be sustainable. In the top right hand corner, you can see an artistic depiction of what an ideal city would be, where you have solar panels on a roof, wind turbines in the harbor. The entire thing is built on levees of hydroelectric dams. It is all very efficient. That is obviously idealized, but we can take some inspiration for that and integrate into cities. And finally, we should spread the message. These changes aren't going to happen if people don't know their support for them. Politicians just don't value green energy very highly because there's no reason to, because they don't know that that's what the people want. You have to have your voice be heard to be represented, and you should contact politicians, let them know that this is a prevalent issue. Don't simply ask for affordable energy, ask for clean and affordable energy. And spread the words, destigmatize nuclear power plants. They are very safe now, very affordable.